Hello, everybody. Hello, everybody, and welcome to another Saturday session of John Chappell Natural Philosophy. So, first of all, I'm going to be putting on the fundraiser video clip because we need money to keep going on. Hopefully, this is the right one. There's a long version and a short one. I'll do the short one.
Hello, everyone. I'm David D. Hilster, president of the John Chappell Natural Philosophy Society. During the past 2 years, we have used annual fundraising drives in order to keep our organization's presence alive and well on the internet. But first, I want to thank everyone who pays their annual memberships through our automatic online system. Your support is vital and provides us with important funds to keep the CMPS afloat. This year, we will be implementing several changes to our online system. Several to save money and lower our annual expenses, and another to better our discussion platform. Our goal this year is $2,000, and I hope we can reach that goal. Whatever amount you can donate, it is greatly appreciated and needed. Your membership and donations are vital to keeping our online community of critical thinkers alive and well. Thank you, and keep up the amazing work that is driving science forward.
Hello, and welcome once again to John Chappell Natural Philosophy Saturday session. I'll put on the ad stage, right. So today's talk is special relativity fraudulent? And hopefully my sound's coming over properly, because in the past we've had problems with the sound. But hopefully I got all that sorted out. There's two people in the green room. Hello, can you see me? Am I all right? He's waving back. I think I'm all right. Not in. Right. Okay. So I think the sound's all right. Just have to keep a check on people if they say the sound goes bad. Right. So is special relativity fraudulent? Now, various people have looked at special relativity and decided that it is wrong. Of course, the mainstream point of view is special relativity is right, but we're sort of dissidents here, and we disagree. We've looked at relativity, and it doesn't make that much sense. So I'm looking at an example of a person who's looked at relativity, and his name is Sjaak Uitterdijk, hopefully pronounced it correctly. He raises the question, is special relativity fraudulent science? And he seems to answer the question as yes. So he's looked at it, relativity, and to him it looks like a fraud. So that I think that's an interesting perspective on it. Not everybody who've decided relativity is wrong have also come to the conclusion that special relativity is a fraud. So this is the book he's written. It's Physics Since Einstein. That's the blurb on the back of the book, and I'm going to make it bigger. He says that the author has worked as an electrical engineer with a university degree throughout his career. So a lot of the time us dissidents are electrical engineers, and when we sort of retire, we then look at relativity and decide relativity is wrong or a load of nonsense. On this particular case, he thinks it's a fraud. So we disagree with these physicists who support relativity. There are other groups of people who look at relativity and think it's wrong. We do have examples of physicists who've looked at it and decided it's wrong. But a lot of time, it's electrical engineers. So this is what the blurb on the back of the book says. In 1905, Einstein introduced his special theory of relativity, and he's abbreviating it as STR. The rumours I heard when I was about 16 years old were that only he and a few others extremely intelligent scientists would be able to understand this theory. And that's sort of the usual propaganda put out there by the people who support Einstein's relativity. A turning point in the history of physics, not only because of this supposed sublime theory, but even more because of the abandonment of the phenomenon of ether. And many of us who are electrical engineers don't understand this reason for abandoning the ether. We think that's sort of nonsense. And so when relativists, people who believe in relativity, start saying there's no ether, it sounds like they're just talking nonsense. Carrying on, until the turning point in history, no physicist ever thought about the possibility that this phenomenon would not be a realistic one, namely that there's no ether. Never thought that would be realistic. But the experiment of Michelson and Morley found them to reject the ether, especially after Einstein came along with this theory in which he did so. So Sjaak, studying Einstein's paper on special relativity, it turned out that at the crucial moment, his mathematical mistakes are so obvious that one cannot avoid believing that he must have made them on purpose. And many of us who've looked at Einstein's paper on special relativity think it's full of mistakes. The arguments for this accusation are shown in Special Relativity, Special Theory of Relativity based on Fraudulent Science, and that was one of the papers he's written. During the development of the theory, special relativity, why a photon is not a particle, it turned out that the potential energy is wrong, and above all, with the wrong sign. And so basically he's then going on off onto his theory, but I'm concentrating on Einstein's special relativity of pointing out it's wrong. So that's a part of what he's talking about I'm looking at in this talk. So this is the paper and the web address for where you can get that paper, and actually he gave me a better copy, so I'm going by the better copy he gave me. So this is something which Stephen Bryant brought up in one of our talks for Natural Philosophy Society. He thinks that when you go through Einstein's 1905 paper on special relativity, you end up with 1 equals 0, which in most cases you would think is mathematical nonsense. Excuse me a moment. So if you put some actual numbers into the equations which Einstein presents to us, you end up with nonsense answers coming out, and that was dealt with one of the earlier talks. And I think what Sjaak is pointing out, he's dealing with the algebra, he's pointing out a similar thing, that Einstein's equations look nonsense. So Sjaak is picking up from this point in Einstein's paper on special relativity, which he published in 1905, and it's a section 3, where you're connecting one coordinate system with another coordinate system. So Sjaak is going by that translation, which I'll just reference, but I've disagreed with that translation in some of my videos, but I'm going to put aside that issue and going by what as is. And Sjaak says, summary, this chapter, because he's put it into a book, shows that Einstein obtained his transformation formulas by applying striking manipulative mathematics, reducing the special theory relativity to a meaningless epistle. An epistle is a letter, so it's basically referring to Einstein's 1905 Special Relativity paper. Sjaak continues, introduction. It is quite easy to show using a highly compressed text what essentially makes Einstein suspicious regarding the said charge, and the said charge is the accusation being made by Sjaak that it's fraudulent. So Sjaak carries on. Einstein defines the relation between x prime and v as x prime is equal to x minus vt. Now, x is an arbitrary time-independent position at the x-axis of a system called capital K, and x prime is its projection as the x-axis of a lowercase k system, and v is the velocity between capital K and lowercase k. So you're talking about two coordinate systems, a capital K and another one. This is lowercase k. In section 3 of his article, this is Einstein, he defines the principal relation between x, y, z, t, and unfortunately in the other coordinate system he's using Greek letters. And I made a note of what those Greek letters are, but for the moment I think I've forgotten them. So it's unfortunate Einstein uses Greek letters, but anyway, Einstein's writing equations to connect those terms together. And so Einstein says to any system of values x, y, z, t, which completely defines the place and time of an event in the stationary system, there belongs a system of values, and that's the Greek letters ones, determining that event relative to the lowercase k system. And our task is now to find the system of equations connecting these quantities. So Sjaak says, surprisingly, he next defines, and that's a Greek letter. If I find my piece of paper. Yes, I found me a piece of paper. So that's a Greek letter epsilon, I think. Epsilon is equal to c tau. And the c is, of course, the speed of light. So his tau is sort of like time coordinate in the other system. Then Einstein says, but the ray moves relative to the initial point of lowercase k when measured in the stationary system with the velocity c minus v, so that k prime divided by open bracket c minus v close bracket equals to t. Now, I've argued a lot with people who believe special relativity over this speed, c minus v, and v is normally taken to be non-zero. And it seems supposed to be light speed, and for v non-zero, so light speed is not c, when by a second postulate it's supposed to be c. And anyway, Sjaak continues, writing x prime divided by open bracket c minus v close bracket is equal to t, as x prime is equal to ct minus vt, shows that the definition of x, which is time independent, has been changed into x equal ct, and it's in red to emphasize this change, though suddenly it's time dependent. Suddenly x becomes time dependent by this equation, and previously it was being treated as time independent, just like the definition of epsilon has been changed in the same manner. So we need to note that x equals ct, because just not going to make sense further on. So Sjaak says Einstein applies this x prime is equal to ct minus vt in the first version of intermediate expressions for tau and epsilon, but returns to x prime is equal to x minus vt in order to arrive at this second version. So Einstein is flipping between one moment using x to be independent of time, and next moment using it to be dependent upon time. And so Sjaak says, so he effectively uses x equals ct only for a while to be qualified as shocking unscientific behavior. So flipping between what x is supposed to mean, Sjaak is pointing out is unscientific behavior and shockingly bad. And so, i.e., that's my comment, Einstein uses x equals ct sometimes and sometimes not. Sjaak continues, section 2 shows in detail that Einstein's mistakes are so extremely obvious that one can hardly believe that he didn't make them purposely. Section 3 shows that the scientific establishment changed after his death. Einstein's hypothesis regarding the speed of light fundamentally, but that it maintained uncriticized the result of his theory. And so section 2 and section 3, which Sjaak is referring to, is we're going to come to presently. So section 2 of Sjaak is pointing out Einstein's unpardonable mistakes. If Einstein would not have made these mistakes, and this is Sjaak still, he would not have succeeded in presenting his consistent transformation formulas, consistent regarding the following property. After having transformed the coordinates of x and t from system capital K to system lowercase k, where lowercase k moves with velocity v relative to capital K. The original coordinates and capital K are found again applying the same formula with the appropriate values from lowercase k to capital K. And so I remind you that the lowercase k is a system of coordinates and capital K is a system of other coordinates. So, as Sjaak is going to point out, Einstein defined the velocity v as follows. Einstein says, now to the origin of one of the two systems, it's lowercase k, let a constant velocity v be imparted in the direction of increasing x of the other stationary system, capital K, and let this velocity be communicated to the axes of the coordinates. The relevant measuring rod, ... It carries on talking, and at the end of section 3, in its article, he writes, this is Einstein, if we place k prime is equal to, no, it's not k, getting confused now. If we place x prime is equal to x minus vt, it is clear that a point of rest in the system, lowercase k, must have a system of values x prime, y, z, independent of time. This is a contradiction in itself because x prime is equal to x minus vt shows that x prime is a function of time, unless x would be x subscript 0 plus vt, with x subscript 0 independent of time, i.e. Einstein is messing up the different uses of x. One moment he's using it as independent of time and next moment is using it as dependent upon time. And so to show the difference between the two uses of x, you should really write them as different things. One you should write as an x, and the other one you should be writing as x subscript 0 or some other mathematical notation. So the question is, okay, if I make my screen bigger, maybe I can see it. The question is, what has x been meant to be? So what does Einstein think x is when he keeps flipping between its use? One moment dependent on time, and next moment independent of time. Sjaak carries on. He says, to answer this question, the final result of the special theory of relativity has to be considered, especially this equation epsilon is equal to beta, open bracket, x minus vt, close bracket. Now, suppose x is equal to x subscript 0 plus vt, then epsilon would be beta x subscript 0. This has for sure not been the purpose of the special theory of relativity. The transformation epsilon is equal to beta, open bracket, x minus vt, close bracket, can, given the relation x prime equal to x minus vt, be written as epsilon is equal to beta x prime. This result is in accordance with the purpose of special relativity, meant to show that due to the velocity v between lowercase k and capital K, the projection of x in lowercase k is not just x prime, but an enhanced beta x prime, given the fact that beta is equal to the gamma factor 1 divided by square root, open bracket, 1 minus v squared, divided by c squared, close bracket. Sjaak carries on. The words independent of time in his text, Einstein's text, system of values x prime, y, z, independent of time, will be ignored. And with Einstein saying this, since tau is a linear function, it follows from these equations that tau is equal to that equation, where a is a function of, that's another Greek letter, it's psi, I think, psi, and psi function of v at present unknown, and where for brevity it is assumed that at the origin of lowercase k, tau equals 0 when t equals 0. Sjaak says, considering the remark, it is assumed that at the origin of lowercase k, tau equals 0, then t equals to 0. One has to conclude that for t equals 0, the variable x prime is equal to x minus vt equals x, and thus tau is equal to that equation. So tau is only 0 if x is chosen 0, but x equals 0 means that the origin of capital K, not of lowercase k, is chosen. This remark of Einstein will be ignored too. So Sjaak, in trying to understand Einstein's paper, is having to ignore certain things that Einstein's saying because it doesn't make sense, to try to make sense of what he's saying. Okay, I might have confused myself here. Yeah, so this is in the next slide, slide 20. Einstein says, with the help of this result, we easily determine the quantities, which is the Greek letters for that other coordinate system, by expressing in equations that light, as required by the principle of constancy of the velocity of light in combination with the principle of relativity, is also propagated with velocity c when measured in the moving system. For a ray of light emitted at the time t equals 0, in the direction of the increasing epsilon equal to c times tau, or epsilon is equal to that equation. And so it's what's given in text in section 3 of Einstein. Einstein says to any system of value x, y, z, and t, which completely defines the place and time of an event in the stationary system, there belongs a system of values epsilon, followed by other Greek letters, determining that event relatively to the system lowercase k. So Sjaak says the definition epsilon is equal to c times tau is fully misplaced, because epsilon now represents two fundamentally different coordinates. So Einstein is making a mess of this use of his mathematics. So Sjaak says Einstein makes here an unimaginable fundamental mistake. Following his misleading approach, he continues with, this is Einstein, but the ray moves relatively to the initial point of lowercase k when measured in the stationary system with the velocity c minus v. So that x prime divided by open bracket c minus v close bracket is equal to t. So Sjaak says, doing so, Einstein changes the definition of x prime is equal to x minus vt into x prime is equal to ct minus vt. In other words, he now effectively changes to the original definition of x as the fixed coordinate in capital K into x minus ct. So Einstein says if we insert this value of t in the equation for epsilon, when you give that equation it's meant, we attain that other equation for epsilon. And Sjaak's remark is the descriptions of the variables are, and so it's eta, that's the first Greek letter one, and other one I think is zeta, are disregarded as they do not play a relevant role here compared to the importance of the role of the variable epsilon. Einstein continues with, Einstein says, substituting for x prime its value, we retain, and it's those equations where he's using that funny function, which I think was psi, which is a function of v, and that's an unknown function of v. So Sjaak's remark is found right after the expression. He's got that equation for tau. Einstein defined already that function as equal to a. So the statement Einstein is using, substitute for x prime its value dot dot dot, and he says the rest. Sjaak must mean in equations where tau is equal to that expression and epsilon is equal to that expression. The question is, however, which value of x prime? The original defined x prime is equal to x minus vt, or the just defined x prime is equal to ct minus vt. And so it's the confusion here of what is Einstein meaning, because he's using x to mean different things. So one minute he's using it as a variable, and next minute he's using it as not a variable. And so it's making the confusion over what those equations, which are just presented there for tau and epsilon, are supposed to mean. So Sjaak says an investigation surprisingly learns that he returns to x prime is equal to x minus vt. Such manipulations show a shocking unscientific behavior. Doing so, the result is that equation for tau and that equation for epsilon. In the appendix, it has been proven that a times beta must be 1. So the final transformations are shown there as for tau and for epsilon. So it's hard to avoid the impression that Einstein used the reintroduction of that function, which is the psi function, which depends on velocity v, here to camouflage as much as possible his manipulative mathematical operations by changing the definition of x prime for a while. So Einstein is doing mathematical trickery here. In order to qualify a theory consistent, it sure needs to be at least in accordance with its premise. In this case, the premise is not clear, given the fact that Einstein up to now uses x equal to x as well as x equal to ct. If the definition epsilon equals c times tau, so that epsilon divided by tau equal to c is taken as premise, the result of the transformation formula is expressed as epsilon divided by tau has to be c2. Also, in other words, given epsilon divided by tau is equal to that expression, it is clear that this condition is not fulfilled except for x is equal to ct. Indeed, given the premise epsilon equals to c tau, c times tau, it's not really surprising. But epsilon equal to c times tau is on its turn contradictive with the most original premise of x prime is equal to x minus vt, in which it certainly is not meant to mean that x equals ct. The shown manipulative mathematics thus has reduced the special theory of relativity to a meaningless paper on relativity, on physics paper. The urgent question is why did and still does the scientific establishment not observe such manipulations? Even worse, why did and does it make unpardonable mistakes on top of these? So basically, Einstein made unpardonable mistakes in his paper, but the mainstream doesn't want to address that problem, and instead it makes more mistakes on top of it, which are also unpardonable mistakes. So Einstein's postulate about the speed of light. Einstein says any ray of light moves in the stationary system of coordinates with the determined velocity c, whether the ray be emitted by a stationary or by a moving body. Sjaak says the fundamental error in this postulate is that he effectively reintroduced with his stationary system the ether model, i.e. when he says stationary system, that can be interpreted as an ether frame, most likely without noticing it. So Einstein, Sjaak thinks Einstein introduced an ether frame, but Einstein didn't notice that's what he did, because Einstein rejected the ether model himself in the same article. So Einstein rejects the ether model, but according to Sjaak, maybe what Einstein's doing is reintroducing the ether frame, but not even knowing that's what he's doing. It's generally accepted that an absolute stationary system does not exist, and that's in the context of special relativity. People who believe in special relativity start rejecting the idea of an absolute stationary system. But in the Einstein's paper, you don't really get that. So Sjaak carries on. As a result, only a stationary system, and this is an abbreviation often used, WRT, which means with respect to another system, can exist. As a consequence, that other system is also stationary with respect to the first mentioned one. Therefore, the introduction of a singularly stationary system is senseless, whether it is put in quotes or not. Einstein even defined it as the stationary system. Let us take a system of coordinates in which the equations of Newtonian mechanics hold good, and he's got a footnote 2 with that. in order to render our presentation more precise and distinguish this system of coordinates verbally from others which will be introduced hereafter. We call it the stationary system. Note 2 is in Einstein's paper is i.e. to the first approximation of, but that is in the English translation, and it's not in the original German paper, that note 2, and I've argued a lot about that with people. That note 2 is not in the original theory. It's in the English translation, but not in the original German paper. But putting that aside, carrying on with what Sjaak says, he says the scientific establishment seemingly realized this mistake too. Instead of combining this mistake with Einstein's mathematical manipulations and as a result reject special theory of relativity, it added another mistake to the story. And the mistake is it changed Einstein's wrong postulate into another one, even more unphysical postulate, by assuming that the velocity of light in vacuum is c relative to whatever reference. Sjaak says it is, of course, allowed to create whatever postulate. However, it is fully unscientific to change the postulate of a particular theory fundamentally, but still maintain the result of that theory without changing even one word in it. Moreover, if such an unscientific act is statistically, given that no reference exists to explain this fundamental change in Einstein's hypothesis, this is also strongly resembles deceit. And I call it making a mess. Numerous changes made to relativity at random, making the whole thing a mess. So Sjaak's conclusions are: 1, Einstein's mathematical errors force us to conclude he should not be regarded as the widespread praised most intelligent scientist ever. And a lot of the propaganda is how much a genius Einstein is, but people like us who read Einstein's paper think it's pretty bad, and Sjaak reaches that conclusion. Einstein, he looks much more like a physicist who has developing his special theory relativity practiced physics in a shockingly unscientific manner. And point 2, shortly after Einstein's death, the scientific establishment not only made an unforgivable mistake too by not openly denouncing Einstein's unscientific behavior regarding his special theory of relativity, they made it even worse. His postulate regarding the velocity of light has been fundamentally changed without changing a single word in Einstein's theory. Such behavior should also be considered as shockingly unscientific. Point 3, the influence of Einstein's unscientific behavior on the health of physical science is dramatic. All modern physical models and phenomena are more or less based on his special theory of relativity have to be rejected. For example, the phenomena of space-time, black hole, and last but not least, E equals mc squared. So Sjaak is basically saying everything should be thrown away because of this nonsense that has been presented by Einstein in 1905. And point 4, Sjaak is recommending going back to the theory which was more prominent at the time before Einstein, which was the emission theory. So my comments are now, it's the main accusation is here hidden in the mathematical mess of Einstein, is that the mainstream changed from Einstein's original postulate about the speed of light to a different one. The original postulate is any ray of light moves in the stationary system of coordinates with the determined velocity c, whether the ray be emitted by a stationary or by a moving body. And that's been changed to the postulate the velocity of light in a vacuum is c relative to whatever reference. Now, care has to be taken when using artificial intelligence, but I decided to have another go and see what artificial intelligence made of all of this. So looking at artificial intelligence now, so the question I put to artificial intelligence is, has special relativity changed its light speed postulate from what Einstein 1905 originally said? And I quote what Einstein was saying. Einstein said, any ray of light moves in the stationary system of coordinates with determined velocity c, whether the ray be emitted by a stationary or by a moving body, to being, which is now the more modern version, the velocity of light in a vacuum is c relative to whatever reference. So summarizing the answer, AI, artificial intelligence, says no, the core postulate about the speed of light hasn't changed since 1905. It's just been rephrased to fit a modern understanding of physics. So the modern way that the postulate is stated is the velocity of light in a vacuum is c relative to whatever reference. That's the modern way of talking about it, and Einstein was talking about it in the old way. And personally, I would say rephrasing was changing it. And so AI, artificial intelligence, is trying to bluff it off that this change has been made. So my next question to artificial intelligence is whether it's a change in interpretation of the light speed postulate. Question to the AI. Einstein 1905 gave the light speed postulate as and so forth. And now it's changed to the velocity of light in vacuum is c relative to whatever reference. Has this been a change in interpretation of the light speed postulate? Question mark. And AI, artificial intelligence, responds yes. There has been a change in the interpretation over time, but not in the fundamental meaning of the postulate itself. So that, to me, I would say change in interpretation was a change in the theory. But once again, artificial intelligence it does its best to try to protect special relativity. So basically summarizing, the whole of relativity, special relativity is a mess, as I've already pointed out, and both the mainstream and artificial intelligence, when you ask it questions, are trying to protect special relativity, even though it's this terrible mess. Really, it should have been tidied up. There should have been something written explaining what the mainstream thinks Einstein's 1905 paper on special relativity means, but they haven't done that. They've just left Einstein's 1905 paper out there for everybody to read, and it's a total mess. And they just build upon that mess when they deal with relativity. So that's basically my conclusions. And so this person, Sjaak, has looked at Einstein's relativity, like many of us has done, and concluded is something really wrong with it. In this case, he thinks the mistakes are so obvious that it must be a fraudulent. Right, so thank you. That's the end of my little talk, and we can now get back to see what comments I've got. Anybody want to stick their hand up in the green room? Their hands. Oh, I got a hand. Let's see if we get that to work. Hopefully everything's been all right. No more complaints. Hello, Nick.
Hello, Roger.
Yeah.
Thank you once again for a truly excellent presentation, and thank you for all the work you've done on that research and summarizing it for us.
Yeah. So Jack, he does do a lot more, but he then builds his own theory out, I think. This is the main attack on Einstein's relativity.
Yes, there was a group of German physicists who made a collection of 3,600 plus papers criticizing special relativity. Very few, if any, of them were accepted into the physics journals controlled by physics academia. But I think what you've done is really a great uncovering, and I agree with all of the descriptions of these fundamental math, logic, physics errors within special relativity. But I do have a different view on the motivation. And I've spent many decades talking with relativists directly, so I have a pretty good feel for their motivation. I have to admit that I wasn't personally talking to Einstein around 1905, but I have my own views on what happened there. I think that Einstein was basically a very religious, very moral person.
No, sorry. He says he wasn't. He didn't believe in religion or something. He sort of like didn't believe in a personal God.
A personal God, yes.
So,
well, there were many instances like he avoided stepping on flowers because they were the works of God. So, well, anyways, we won't get off on that tangent.
Okay.
But
not to religion.
I think what happened through the entire history of physics academia and special relativity was that, particularly in the early decades, was that they had a particular philosophical view that led them to put aside analysis when they saw something that would back that philosophical view, when they put aside their normal critical thinking mode and tended to accept it. In later decades, I think that's when the deception turned in, when they realized that there were fundamental problems with special relativity, but that would break the foundations of their philosophical beliefs and also crush their egos for having backed the wrong ideas. They were viewed by the public and the mass media as being the most intelligent people in the world, and they didn't particularly want to look stupid. Einstein had a little bit of that in him, but he was more honest in that regard. So I think with Einstein, he went along with MMX, disproved the existence
the Morley
of the
experiment, MX.
Yeah, but right.
Yeah.
And so he then looked at it as a math problem. How do I get a math/physics solution to there being no ether? And he worked backwards, and he used his well-known inadequate math abilities and came up with a solution. And the fact that his math seemed to him to solve this problem, he tended to overlook and didn't look as deeply as some of the critics that you talk about looked. So he didn't see these glaring errors. And then once it brought him great fame, then he was all the more reluctant to admit it. But in many cases, he admitted the errors, but was then totally ignored by the physics academia, who had another vested interest in supporting special relativity. Now, Einstein, essentially in 1916, Einstein admitted that the twin paradox was a real problem and reinterpreted his original physics interpretation of the time dilation equation. But ironically, in the great twin paradox debates with Dingle, the rest of physics academia ignored this insight of Einstein about there being a fundamental error in special relativity, and which was also backed by Max Born as being a fundamental problem, and went on saying, Einstein is infallible, therefore, Dingle, you are wrong, in essence. So, and then later on, maybe starting in the 50s, the relativity theory was considered foundational to the philosophical ideas that pervaded physics academia and allowed them to do such things. I don't want to get into politics, but just as one example, it allowed them to do a lot of thinking that was as observer-centric as special relativity is. One example being, instead of saying you're a man or woman based on biology, based on science, it really just depends on how you view yourself.
Trump, I think, brought back as only two. Trump's brought it back as only two now. It used to be hundreds.
So the thing is that I think to a large degree, it's the problem was if someone has a preconceived idea or deeply held philosophical view, they can, even though they're a physicist and have done lots of logical thinking and are adept at mathematics, can overlook problems with math and physics if it threatens their strongly held belief system. And I think that was definitely an operative in Einstein's early years. He overcame it, but by that time, the love of special relativity as being foundational to a philosophical belief system was so strong.
Sorry, you're breaking up now.
Oh,
you're breaking up.
Okay.
There's something going on here.
I don't know. Maybe someone else, if they have their picture showing, it can turn off their video for a little bit, and that might help.
Try again. I didn't get the last bit. Sorry.
Okay, just saying that I think the main thing for a lot of people, including Einstein, was not that they were being fraudulent, but they had a strongly held belief system.
Yeah.
That led them to errors, and then for his follow-ons, that led them to overlooking these errors. And when there's some,
I think James wants to come in. Do you?
Okay.
I'll put James up. Okay. He wants to make some comment. What do you say?
Thanks, Roger.
I think he's talking.
Actually, well, Nick, before you go, Nick,
yes.
What were the vested interests that you spoke of in the earlier times? Actually, I just had my hand up as a position, not waving to come in. But now that I'm in, I'm glad because I'm curious as to Nick's view as to what he mentioned, quote unquote, vested interests in the early years after 1905, sir.
Okay. In the early years, it was a vested interest in believing that there was no ether. And it was not as deep as it became later on. So in the early years, very few thought that special relativity was correct. There were very strong opposition to that idea. And some were accepting it because they were very strongly against the ether. And one of the big changes came in 1919 when we had that experiment in Africa where they they claimed to see the bending of light during eclipse, and that seemed to endorse general relativity. And after that, academia as a whole seemed to have a very strong interest in it, because by that time they were becoming much more relative. Everything is relative was fundamental to their belief systems, and it became stronger and stronger in each decade. And right now, I'd say that academia is monolithic in those philosophical views, with a few people objecting to it, but they are able to cancel or quite often get rid of those people and keep it as a monolithic barrier to critical thinking. Does that answer your question, Jim?
Yes, thank you. Thank you.
That's
I might throw in while I'm up just a comment that one thing special relativity has done, perhaps, is to really attack the fundamentals of physics, because when we even look at the units of measurement in physics of mass, length, and time, all of these things now can be changed depending upon where you are, I guess, according to special relativity. And this might be interpreted as a frontal assault on physics itself, the whole foundation of physics.
well, related to that, some philosophers have written that special relativity changed the definitions of time and space, as some of the people that Roger alluded to also mentioned, defining time and space in terms of time. And some were saying that time was redefined in terms of the speed of light. For example, I think currently in the standards measurements, time is defined in terms of the speed of light. So, and they commented that this was done without any arguments as to why. What were the physics arguments of why time and space definitions had to be totally redefined?
Exactly. Yes.
Yeah. So I'm not just speaking as a single person. I mean, these were mainstream criticisms for a couple of decades, and then critical thinking seemed to go out of fashion in physics academia and became sort of a monolithic. Peter Hayes called it as rather than physics, it became kind of an adhere to physics or an adhere to religion, rather esoteric religion.
I may be wrong, but I've noticed in various social media discussions of science and relativity and such, that young people are really coming up with some good questions. Like one student, let's say, asked a question recently on Reddit: how could gravity bend light if light photons have no mass? In other words, young people in physics, I think, are seeing the holes or logical gaps in a lot of this theorizing that is mainstream now, and I consider that a good sign. I don't know whether Nick has a comment on that of how photons could possibly be bent by a large passing by a large mass, if photons have no mass?
Well,
I mean, the students are asking this.
I think they explain it in terms of curvature of space-time. But, the NASA records say that beyond I'm forgetting the right name, of the sun, there is no bending. So the bending really is a factor of the index of refraction of the lighter atmosphere around the sun. Roger, a couple of other points let me bring up. You were talking about AI, and I've been very interested in your interactions with AI and your descriptions of them. But I wonder if we fed into AI dissident physics papers, if that might make AI a little bit more intelligent in its replies.
I don't know where AI, artificial intelligence, is getting information from. I presume it's just
basically they feed into it Wikipedia level. In other words, currently accepted theory. So what you're going to get back, currently accepted theory.
So Wikipedia is censored from distant point of views.
At least AI is intelligent enough to send back qualified accepted theses.
Yeah, I tried asking it questions about distant science, whether it agreed with it, and give the normal mainstream sort of point of view. It doesn't take distant science. If you I've asked it questions, is there mistakes in relativity and things like that?
Yes.
You come back with comments.
Yeah.
And its problem, the normal one they point out, the problem with relativity is it doesn't combine with quantum physics, so it's admitting there's problems with relativity. But it's just the standard mainstream point of view on things. Because relativity is supposed to work, and quantum physics is supposed to work, but they can't get the two to combine properly.
Well, my main point was that I think the reason why physics academia overlooked these glaring problems that were well defined, clearly defined by the authors that you bring forward, as well as in 3,000 other papers up to 2003. I don't know how many it is now. It's one of the basic facts is that special relativity is considered to be what validates their theory. So their philosophy, and that's the one claim to it being based in science. So they have to cling to that, because if special relativity goes away, all of their thinking goes down the drain, which is very hard for someone who's
the modern physics from the 20th century pretty much starts with what Einstein was talking about from 1905 onwards, and so it's all built on that. And even quantum physics is based a lot on what Einstein said, even though he rejected that.
Yeah.
He rejected what they said about quantum physics, but initially he was saying a lot of things that they incorporated into quantum physics. So if they sort of like throw Einstein out, throw him in the waste paper basket, then that's an incredible amount of physics to throw away. If you look back in the historical...
But I do think that Einstein was quite honest, and it was just a case of really, like much of the problems in physics today, he viewed the results of Michelson-Morley, implying that there was no ether, as a math problem. And he started with that and worked back the best he could mathematically. And he came up with the right answer in that context. And once he'd seen it was the right answer, then he turned off any critical analysis of were there any mistakes in his line of thinking. and that's
The trouble
followed
is,
today.
Einstein's paper, 1905, when he starts, he doesn't mention the Michelson-Morley experiment. So you've not really got a theory built on experiment, the relevant experiment in Michelson-Morley, but he doesn't talk about it. And what seems to be that he built upon was his thought experiment about chasing a beam of light. So you're not actually built on empirical evidence for his theory. It was Lorentz who was trying to make sense of the Michelson-Morley experiment and came up with the mathematics. Then Einstein seems to have not done that. It's sort of, it becomes Einstein doesn't make it clear whether he knew about the Michelson-Morley experiment in 1905. When they've asked him that question, sometimes he said yes and sometimes he said no, I think, in the literature. So they don't even know if special relativity is built upon that. But it seems to, when they do ask him, he talks about a thought experiment, about chasing a beam of light. So
Right. But he stole all of Lorentz's equations and then just reinterpreted them from a physical theory to a pure math theory that has no relation to physical reality.
I think he mentions it's Lorentz equations in his paper or something.
Yes.
But he doesn't cite what paper of Lorentz he's going by. So
the fact that it's there.
He hasn't. I think he mentions Lorentz something in the paper. So, but he doesn't. We don't get a reference from what he's working from, which makes it infuriating.
What Nick just said a moment ago about the whole thing coming crashing down, I think is a point that needs emphasis and may pertain to this idea of vested interest today. Because if the whole thing, as Nick pointed out a minute or so ago, if the whole thing comes crashing down, a lot of people are going to lose prestige, possibly possible tenure appointments in universities and so forth that they're working toward. And so a lot of people are going to be in economic as well as intellectual distress. And so this whole thing, in other words, we're sort of looking at an extinction level event.
And it goes beyond just physics. I think it would greatly impact the mainstream press and how they reported on this, as well as a large portion of politics.
And it has occurred to me, oftentimes in the CNPS discussions, as well as on the Sunday cosmology discussions, it's talked about what leverage do we have to influence people with regard to the dissident views that many of us have. And one tool might actually be lawsuits. Like once you introduce the idea of fraudulent behavior, then you start to have victims of the fraud. And those victims might have standing in court to actually sue for damages. Okay, so this is sort of an interesting thing that might be an avenue to look at.
I don't see who you can. I don't see who you can possibly blame for it. You look at Einstein's paper, and maybe you can come to the conclusion that it's fraudulent.
Well, the agencies that are funding certain privileged, very small groups of principal investigators with multi-millions in funding for various projects might be, subject to such lawsuits.
Well, I think
because they're using taxpayer money to promote hoaxes, basically. For example, the Grace satellites supposedly to measure gravity were based upon general relativity, which of course requires special relativity as well. And my analysis of their own data showed that they were basically measuring ocean temperature and not gravity at all. And so, in other words, the whole people are applying to use taxpayer funds to finance projects and their own self, by the way, with large salaries and probably kickbacks on these contracts as well under the table, to based upon you know a hoax. And so, you know, there might be some legal standing here. I can understand why some of you guys might say, well, that really doesn't have much chance of being workable. But, you know, like, hey, now is the time that people are pointing out that taxpayer funds are being used by people to enrich themselves and increase their own prestige at the expense of the taxpayer based upon fraudulent information.
You may think
so
that I'm joking, but I think a more practical thing would be to try and influence DOGE and Elon Musk to cut the funding of physics academia and other.
Oh, exactly.
Yeah.
Because if you just look at CERN, they boast how they have hundreds, and in many cases, thousands of physicists and engineers around the world on their payroll and, you know, doing busy work, basically, based upon failed theories.
Well,
And if these funds were cut, these thousands of physicists would say, hey, oh no, now I have to start thinking for myself for a change.
Either cut or perhaps
there'd be
distributed
protests.
more equally to the CNPS and their officers.
What was that about the officers in CNPS, sir?
No,
that they would distribute taxpayer money more broadly and not just to one corner, put some money into the CNPS and other dissident groups.
Oh, I see what you're saying. Yes, of course.
no, people would start protesting if you stopped funding science. All those people at work, they would start being on protest marches, and they'd start condemning the government, whoever's in charge, as being anti-science, and they would get a lot of backing from that. And as for the trying to do it as a court case, there's a vast number of them who are supporting Einstein's relativity, and they're sort of like the experts. So the expert opinion would be that Einstein's relativity is correct. So a court case wouldn't really work because they would be going by expert opinions. So both approaches don't work. And if you look at it, it's only if there's enough people in academia who decide that it's wrong, and they start a movement then themselves and reject it in favor of some other theory. And you got to bring to their attention what is actually wrong with what they're saying. So it needs a whole open-mindedness of the people who are deeming themselves the expert to suddenly realize, oh, it's probably not quite right. But I don't see any other way.
Well, it could be in this possible extinction level event that the dissidents, with some 3,000 papers that were mentioned, would be a sizable group, more populated to a greater degree than the so-called group of experts.
Yeah.
Well, let me bring it back to the pure physics area a bit. I think when academia, I know special relativity has happened 120 years ago when we haven't made any progress, in fact, gone backwards since then. But I think 200 years from now, and the people in history of science will look back on this era, and they won't even mention the actual physics. They'll just raise the question, looking at this era of dark physics that propagated dark energy and dark matter, etc. What they'll focus on is how could this have happened to an area that's not like fashion, but supposed to be based on logic and math? How could it have gone down this path? And that will be the main topic.
Well, they reject. What physicists seem to reject certain types of logic. When you get onto the quantum physics in particular, then you're supposed to have a different logic for that, to what is commonly known. So they managed to play around with that, so you can't really win from that direction. Got Richard, got Harry here. Hello, Harry. Hi.
Hello, Harry.
Yeah.
So basically, if you look at the history, yes, I'm gonna put forth the history of science is big changes occur when people come up with changing new technology that upsets the apple cart. And that's not really on the horizon quite yet. But they've been working on nuclear fusion for, I can't remember how long, and it's been a massive failure, and they're still spending money on it. And I don't think that we're really going to get new physics until somebody comes up with a new way of thinking that can produce energy, okay, and a very high level that's safe and effective. And I think that's going to happen. I'm surprised Elon Musk's not working on it. But they've been how long have they been working on nuclear fission and wasting our money, our taxpayer money, on something they've never been able to accomplish? And so I would say technology is what changes thinking in physics, really. That's what history shows. And so it's technological change that forces the change in academia. I don't think academia, they just basically hold on to the existing ideas and keep repeating them until some new revolution occurs in technology that changes things.
Well, they could have done
Does
it.
That make sense to you, Nick?
They could have done it with GPS, but they didn't.
Yes, I was going to say GPS.
No, they didn't do it.
GPS.
So where are we? Excuse me?
GPS proved SR wrong.
Yeah, that's an interesting point. The problem was the engineers designed a system that didn't use special relativity.
Unfortunately, the management of GPS cannot admit that they don't use special relativity, as they'll lose.
Well,
funding.
we know that GPS isn't really based on special relativity,
right?
But
right.
That's an example of what you were saying, Nick, which is the physicists who then wrote the explanations in the textbooks claim, no, it proves special relativity is correct when it doesn't use special relativity. And, so you're just based on.
Right. Ron Hatch, who has 30 plus patents in GPS and one of the key experts in the data, has for decades says the GPS data shows that special relativity is wildly wrong. But management won't admit to that for management reasons.
It's supposed to be that they collect the data from.
Okay, Roger, I can't hear what's going on.
Okay. Okay, well, it's supposed to be from GPS that they collect the data.
I can't hear what he's saying.
Okay, sorry.
Well, Roger, let me
Can you hear me?
I can hear you. Can you hear me?
Excellent.
Yeah, I'll speak louder. Let me see. Let me hear.
No, I can hear you. It just Harry couldn't hear me, so I don't know what's going on with these sound things. It plays up, doesn't it?
Let me bring up some other physics
Put
points.
the volume up. Yeah.
I guess it was Sjaak who said that Einstein went back to the ether at one point.
Yeah.
But I don't think that's quite a correct interpretation. I think he identified clear error. But in my debates with physics academia professors on the twin paradox, what they did, they won't admit it, but their logic directly infers what they did is when they look at frame S and frame S prime, they treat both frames simultaneously as the single preferred frame. So that in essence, what Einstein said, and I think his mathematical steps really led to this interpretation, was he was treating all inertial frames as the single preferred frame, which obviously is incorrect and would lead to total disaster.
I think Einstein was admitting to people, this is in later life, such as Michelson and Lorentz. I think he was admitting to them that the ether exists. The trouble is he didn't go back and then discard all the mathematics, which would then have been wrong. Mm-hmm. So you're saying one thing, and it's sort of like he still left the existing mathematics standing. So he didn't go back and tidy it up or anything.
Yeah, I think at that point he was influenced by the fact that he had so much fame that he loved that he moderated his candidness.
Yeah. So just saying to people, I've changed my mind, the ether exists, and people looking at the mathematics and saying, how does that connect to the mathematics? And you should have tidied up his mathematics and said, here is the ether in it. But he didn't. He was supposed to be having problems with mathematics in his later life. And the usual story is that he was trying to work out the mathematics of a unified field theory, but he never got to it. And that's more sort of like propaganda. But the people that look to Einstein as their hero say he was good at mathematics, but then people like distance like us who look at his mathematics say no, he was terrible at mathematics.
Yeah, I think in school he failed math.
Yeah, well, that is arguable, I think, as well, because people point out that he had good grades. But it's sort of like it's nothing. I think it's Minkowski was his maths teacher, and he said that Einstein was bad, but that's not what the propaganda goes by. They don't generally accept that, and there's not enough information that came from Minkowski about precisely how he thought Einstein was bad at mathematics. So in the propaganda side of it, where Einstein's a hero, they managed to push that thing aside and say, oh, his mathematics is brilliant, and so forth. He was good at mathematics. But when you look at his paper, it for people like me and Sjaak, you look at it and it's bad. But then you've got people who look at Einstein's mathematics and say, oh, that's good mathematics. And you go, what? And these people were saying it's good mathematics because I've gone through what Sjaak has pointed out now, going through Einstein's mathematics about how Einstein messes up between the different ways x is to be understood in that equation. One minute it's independent of time, the next minute it's dependent of time, and it flips backwards and forwards. So the mathematics is bad, but not everybody sees it that way. Some people must, from my point of view, be bad at mathematics themselves, and so they, when they see bad mathematics from Einstein, they don't see it as bad mathematics. They see it as mathematics is okay. So you've got the split between people again on that issue, which is terrible. Everybody can't agree what is good mathematics.
All right.
So you've got the defenders of Einstein, and they look at what he's done and think that's good. And you've got people, critics like myself and others, and look at it and say, "Oh, that's bad." And there's no way of communicating.
I think the one thing that Einstein did in its basic assumptions that led to his erroneous derivations, and also led to another general area of incorrect thinking, was his view of inertial frames. He's looking at a velocity-dependent phenomenon in time dilation and length contraction.
Yeah.
So to make things simple and to eliminate all other forces, he just said, okay, we'll just look at inertial frames, because if you're an inertial frame, then you don't have other forces accelerating that frame. So you can it simplifies the problem mathematically. But unfortunately, what came out of that was that he gave inertial frames a special status, which they don't really deserve in terms of fundamental physics, because it turns out that inertial frames don't have any special status for a velocity-dependent phenomenon, like time dilation or clock retardation or length contraction. It's a matter of instantaneous velocity, and you can be in an accelerated frame, and the equations would still work as long as you use integration. But so many relativists, like in the twin paradox debates I've had, they talk about the traveling twin accelerated, and therefore he cannot use special relativity.
Yeah.
And they did what I pointed out, these errors and the GPS data to relativists. They say, well, the Earth is rotating and the satellite is rotating, so it's not inertial. Therefore, you can't use this data to get rid of special relativity. They see the problem, and the only way they can get rid of it is saying it's invalid data. But go ahead.
Some people, when they talk about special relativity, they say it doesn't deal with acceleration. Then other people say, yeah, you can deal with acceleration and special relativity. And the people who say you can't have made a mistake in saying that. So you're onto people who've got conflict of different beliefs all the time. So the transition of how special relativity deals with acceleration and eventually becomes general relativity is a mess. You sort of like, in the context of Newton, you would be dealing with flat space-time. And then suddenly Einstein it does his inertial frame stuff, special relativity. And suddenly further on, Einstein brings in, or instead of bringing in gravitational force, he brings in space-time curvature. So the whole thing is a mess. It's sort of like you're building on more and more. It's sort of like, what? You've done away with gravitational the usual way of representing gravity as a force and replaced it by space-time curvature, and it doesn't make sense. As you how do you transition from special relativity's flat space-time to curved space-time? It still doesn't make sense. One of the things when they were teaching me, the must decades and decades ago, that they were talking about terms of relativistic mass, and nowadays there's a lot of people who believe in relativity say there's no relativistic mass, but back in my day, they had relativistic mass. So if you're in a spaceship and you go faster and faster and faster, and you get to a very high speed, then the mass of that spaceship would be increasing. And so, putting aside the issue of burning fuel and all that, say you could have a propulsion system where you didn't lose fuel and so forth. Your spaceship its mass would be increasing, and eventually, surely its mass becomes so great that it would turn into a black hole. And so that's what was my thinking. You go, whoa. So they never, when they're teaching you special relativity, they're not going into the gravity side of things. And so,
yeah, I wrote a paper on that.
Yeah, I should send it to me. I need to look at that. Please send it to me, because it ever so confused me. So I saw my thinking was, oh well, they're talking about special relativity. They've got mass of an object, so therefore there must be gravity involved in it. But they're not talking about gravity, and that's in the context of Special Relativity 1905 version. It's later when they bring in general relativity, they're going to have that mass as being connected to gravity, but not by a force, but by space-time curvature. And you're thinking, it just doesn't make any sense, doesn't it? Sort of special relativity, if an object's going fast enough, it must break down, and you can't ignore gravity anymore. The object becomes so massive, it must be the end of that. In sort of special relativity, it causes its own destruction. But now, when they're saying there's no relativistic mass, I think that was brought in to try to overcome that problem. That a spaceship, if it goes too fast, would turn into a black hole. I think it's all. It's sort of like they keep adding things, changing things to what they're saying about relativity, and it's sort of like it's not. It's as that Sjaak's pointing out in his paper. It's unscientific what they're doing. It's sort of, yeah, you can change the theory. Yeah, we allow you to change the theory, but when you're not making it clear what you're doing when you're changing that theory, then that's very fraudulent. It's unscientific and looks fraudulent with all these changes they're making to it. But when I try questioning AI, artificial intelligence, it's doing its best to try to defend relativity and saying, no, it's not a change in the postulate, it's a change in the interpretation of that postulate, or it's a change in the rephrasing of that postulate to say to a more modern usage. But the postulate hasn't changed, and so that's all bluff. It's if you change the interpretation, if you change the way you say it that is changing the theory. But AI doesn't want to accept that, and most people who want to believe in relativity don't want to accept that they're making all these changes, but they don't accept that they're making these changes to it. So it then translates to me, well, it's all a mess. They messed it up. It's not a proper science anymore. It's just mess. So I think that's
one example. One
Yeah.
example of that is, and you mentioned it, is like in the twin paradox.
Yeah.
When the obvious error that Dingle pointed out.
Yeah.
They say that, well, you can't the traveling twin cannot use special relativity. They're really saying that because that would lead to a contradiction if he could use it.
Yeah, but it's different people.
But their excuse is that he accelerated. So basically, they're saying, if you have ever accelerated or ever will accelerate, then you can't use special relativity, which basically
Yeah.
would mean special relativity is useless. But all the
Yeah.
relativists will nod
Well,
their head. If it sounds plausible escape for them, oh yeah, that's all. That gets rid of that dissident argument.
But they talk about it in different ways. Some people do accept that the special relativity can deal with acceleration, as opposed to those people who say it can't. So they come up with all these different excuses, and they believe different things, and so that's relativity, just a mess of different things being said which are in conflict with other things that people are saying, and they should tidy it up, but they can't. It's a mess.
Were there any questions from YouTube or the?
I looked on the comments, and they seem to be going on their own conversation about things.
Oh.
When you start this talk, it's people are then talking about things between themselves about things, and it's hard to pick anything which they're saying relative to what my talk was about. So I didn't really see anything. They're talking about light speed and things, and it's only between themselves. And one person asked for the link to this session, and I sent the link to StreamYard session, but he didn't come on. So I gave the link, and he didn't come on. So I don't know. So they all want to talk about other things. One person suggested I write a paper about everything I think is wrong with relativity, but that's too big a subject. It depends on how many things you're looking at on it. There's special relativity, general relativity, and then all the changes that keep getting made to it. And this session was about Sjaak, how he looked at a paper and came to the conclusion. It does look fraudulent, and I can see his point of view. He's pointing out that the variable not the x is sometimes treated as independent and sometimes treated as dependent. So it's the different ways that x is being treated in the same equations, and so that's making a mess of things. And ideally, the physics establishment should have looked at Einstein's paper and tidied it up, gave their version of what Einstein is saying with the maths tidied up, but they haven't done that. So they've just left it as a mess. And the other point was on the other thing, that the postulate, Einstein's postulate about light, they say it differently. They don't say it the same way Einstein says it in this paper. It's the way you read Einstein's paper, when he talks about the stationary, I think it was frame. When he talks about that, he must be talking about an ether when he says that. But then earlier he says there's no ether, so that's not clarified. It's sort of like, well, he's contradicted himself. And some people look at it and say he's contradicted himself about what he says about the ether. So then people go off in this direction of Einstein. According to Einstein, there's no ether, and other people take the direction. According to Einstein, there is an ether. So people get split again. It's just too many different directions people go in as to what they think Einstein meant. And so that's the mess we're in. Einstein, the foundation of modern physics, that's from early 20th century onwards, and it's just a pile of mess which has been added to. Rather than tidy it up, they just kept adding more mess to it. And on that issue, though, the people who support it, that they managed to get their medals and awards such as Nobel Prizes built upon accepting it. It's sort of like their expertise. Yes. their expertise is based upon believing it. And I believe it, and they say, I found this particle, what do you call it, Higgs particle. I found this Higgs particle. Give me a Nobel Prize. Yeah, okay. What else you found? I found gravity waves, all based on Einstein's relativity. Or give us a Nobel Prize for that. Yeah, I'll give you a Nobel Prize. So it's all built. It's all money making. It's all money making to buy into Einstein's relativity. You just say you have to believe it, and then what you can do is just you can put your own interpretation on it. So you've got your version of what you think it means. Everybody else has got their different versions, and you just say, well, those people with their different versions, they don't properly understand it. I'm the one who understands it properly, they say. And so that's the mess they're in. They've not presented it properly in the theory. They've just allowed people to go in whatever direction they want to go in, believing whatever they want to believe about it. So that's modern physics. So I think I'll end it here. Is that enough, Nick?
Well, yeah, let me just add a few points.
Okay.
You brought up the Higgs
Yeah.
article and winning the Nobel Prize.
Yeah.
At the microscopic level. But
Yeah.
Smoot also won the Nobel Prize.
Yeah.
And he wrote about it in his book, Whispers in Time.
Yeah.
And that's the grand cosmological point of view. But as Professor Unzicker pointed out, they both made the same mistake. They came up with a possible solution to a problem with relativity in modern physics. And their first attempts failed. So then they looked at even more data and lowered the bar for acceptability. And they kept doing that and doing that. And as Unzicker pointed out, eventually, if you have enough data, tons of data being massaged by the computer and filtering out all the things that don't come up with what you're looking for, and then you finally find something at the much scarcer level. And this is the thing that will win you the Nobel Prize and have all your colleagues congratulating you and showering you with champagne. Yes, you accept that, and that's what you publish. And it's it's not just you and me and a few other people here on Saturday morning who are talking about this. I talked about the German group of physicists who put together 3,000 research and found 3,600 papers published about the flaws in special relativity. And there have been maybe 1,000 more since 2003. And you had Einstein himself, who was agreeing with us on several of these points, but physics academia just ignored it and kept him as, an infallible God, but just overlooked where he disagreed with his original thesis that they have clung to. And regarding the Dingle debate on the twin paradox, he was one of the premier physicists and relativists of his era and highly regarded until he came across the twin paradox and was convinced that special relativity was wrong. And then he was tarred and feathered and ridden out of physics on a rail. And he had a decade-long debate, which was the twin paradox debate, which was quite famous. And the Harvard physics, I'm forgetting his name at the moment, Chang, I think, did a detailed analysis. And while he remained a relativist, so he was not biased, he said the counter arguments to Dingle's point were never raised in that 10-year-long debate. He never addressed the point he raised. So we are not alone in our thesis.
All things. Okay, I think Jerry
Thanks once again, Roger. Great.
Sure then. Bye then. Thanks. Bye. We move. All right. Okay. See at the stage. Hello.
Hey, how's it going?
Okay.
Can you hear me?
Thank you. Yeah, I can hear you.
Okay, cool. I'm on my other computer, as you can tell.
Oh, great.
Yeah.
Okay. New computer, is it? My
it's the laptop that I usually have downstairs. Though
my desktop is playing up, so I'm on my laptop.
That's
Computers
cool.
are computers are a bit of a bane, aren't they? Really?
Oh yeah, some of the time when they aren't working properly, for sure.
Yeah, and so it gets to a stage you think, I can't live my life with the computers not working because I'm so into being on the web now. So like, how can people
that is
a life without a computer telling you what to do, looking up things and how to do plumbing and things like that? Well, we'll be able to do
almost anything.
Anything? No, all the information is on the internet.
I guess encyclopedias just. I mean, you never see the salesman anymore. Coming to your door. I mean, the internet tells you way more than encyclopedias ever could. I guess people might collect them just as antiques or just sort of as, just for convenience sake, or maybe what's the word? What's that word? I don't know. I can't think of it right now.
Survivalist is probably. I don't think. Take away my computer, I wouldn't survive. Can't live without being in this sort of social structure. Take it away. No. If it's sort of like if everything came to an end, you'd need to know how to do farming and that. With information.
Oh yeah, I've thought about that so many times.
Without access. Without access
I mean, if all the knowledge is on computers, where do you just vanish? I mean, how would civilization survive?
I wouldn't survive. Couldn't survive.
I mean, it would seem highly exceptional to get anywhere near. Like if we started out from scratch. I mean, even with the knowledge, it would take forever for people to learn the knowledge, build everything, get things running.
Yeah, just doing it wrong.
Living today.
Just doing your farming wrong for a few years, and you soon starve to death and die. You wouldn't learn. You wouldn't have time to learn, would you?
No.
Okay, so we'll be on back to relativity. Did you?
Oh yeah.
Enjoy the talk?
I have to admit that I don't always understand. I usually don't understand when there's math. Yeah, that's sort of my personal quirk or disadvantage.
Yeah.
I've thought of trying to study up on some and seeing if I can decipher. Well, okay, here's where my point of view coincides with this mathematically, because I think it must possibly exist, like that I can recognize it in those sort of terms, But as far as a lot of the complex math, being different theories, it seems that we could just closely examine each one and just point out with each single one, just say, well, this is mistaken there, this is mistaken there, and so forth.
There's too many mistakes.
I guess you've done that though with your many videos to some extent, at least. Probably to a large extent.
There's too many mistakes and too many different ways of trying to understand the mathematics. Yeah. And then when you go to what's being said, and you point out what's being said doesn't make sense either.
Yeah.
And so it's just too big a subject.
Yeah. Well, we know how. I'm sorry.
Yeah, but when they talk about it in general, they say the mathematics simple algebra for special relativity. So only with general relativity, the mathematics gets really hard.
Well,
you just need
if they can confuse and disguise things with words and concepts, I'm sure they can figure out a way with symbols and letters and numbers.
Yeah. But it's sort of like he talks about things, then you have the mathematics, and what's he talking about doesn't make sense. Then you go to the mathematics, and that doesn't make sense. And then you say, well, the next thing is to look at the references to see what he's working from, and he doesn't give any. Said,
really? Yeah, I don't think Einstein provided references in his 1905.
That's what I mean, yeah. And so these people then see you can't learn it from Einstein's papers. It doesn't make sense. But then you go to, I've been to various classes where they teach it, and they change the theory. They come up with their own personal opinion about what the theory is, and so they're teaching something which is not necessarily what was taught decades earlier.
Yeah.
So they just keep changing it.
I've definitely heard many variants of the theory through books, videos, through individual people who I've spoken with. Yeah, I mean, there's quite a variety of Well, I mean, a lot of them are similar, and a lot of them
Yeah.
focus more on certain things than others.
Yeah.
However, though, well, I had a question as far as you know how the Lorentz transformations and special relativity were meant to account for the invariance of C.
Yeah.
I mean, I don't know if it started from where they were typically picturing themselves like an observer or a light source being present, or electromagnetic source, where if it always clocks at the same value, however fast the observer or light source travel, that there's that discrepancy that it seems like linearly it would increase or even grow in the opposite direction towards away from the source of light. However, though, then they apply that to objects, though, somehow, which I haven't ever understood. I mean, of course, a light source has to be an object. However, though, when there isn't light present at all, the theory somehow continues to apply, which I haven't quite ever understood.
I think it might be the print relativity of simultaneity, maybe. Because
what is it?
If you've got an object, it's moving. Then it's emitting light from that end, and it's emitting light from the back.
Oh yeah.
And then they're saying, oh, that. So from seeing those two light things, you're working out what that distance is from that light to that one.
Yeah.
And they start talking about that light doesn't go at the same time as that one. So
yeah, like if they're an observer on each side, it will allegedly clock the same, even though. Yeah.
So that light is emitted at a different time to that light, and so when you're trying to work out the distance, it's variable.
Well, wasn't that the way the Lorentz transformation worked, though? That there are units that would increase or decrease, at least decrease exponentially, at least in length. Mm-hmm. I don't know if it's applied to mass or energy or even time. Yeah. Because the way the Lorentz transformations work without special relativity is that if the units transform, like objects that exist within that vicinity, do they transform with it to make things seem consistent?
You're talking about Lorentz theory.
Yeah. Well, also as opposed to special relativity.
Yeah, you got the Lorentz theory and you got Einstein's theory, so. It's how you interpret it in the mathematics. So it's all sort of like very confusing.
Yeah.
With Lorentz, you haven't got most of the things that Einstein's saying.
Yeah. Well, I mean, didn't Einstein basically sort of apply what Lorentz had said with the units?
He doesn't reference
that applied to real life objects or
he doesn't
life size.
Einstein doesn't reference Lorentz's paper, so
really?
Say what. So
isn't that where he got the idea of length contraction and such? I mean, that's got to be where he got the idea.
I don't know. He mentions, I think, Lorentz once in his paper on special relativity.
Well, he was also quoted as saying that he hadn't heard of the Michelson and Morley experiment, but he's also quoted saying that he had.
Yeah, that's right. So that's very confusing as well. So Einstein's very confusing. It's very difficult to make sense of what he's going on with.
Well, it seemed that a lot of the questions raised by the Michelson and Morley experiment could conceivably lead to ideas within special relativity that he dealt with. Even if he dealt with them in a mistaken way, it still raises points to consider as far as what he was dealing with. They're valid. I'm trying to think of the terminology. Do you know what I'm trying to say? The areas of research that are valid to consider. Even if he arrived at incorrect conclusions.
Yeah.
Sorry, this keeps shaking.
You still got the mathematics, and you can make amendments to it or whatever.
I'll get going on that.
So okay. Thank you. I think.
Thanks a lot. Appreciate it.
Thank you.
Good seeing you.
Okay. Might be Cornelius wants to come on. Right then, thank you. Bye. Is you Cornelius? Do you
come in? I was just going
Right.
to come in while Jerry was in there talking, because it looks like you ended the conference, but I think the conference is still going. There's still people on the sideline making some chats and that too.
Yeah.
So, now I'll go
Okay.
talk to Jerry offline. There's no point in continuing
Okay.
with the online
Okay.
stuff.
Thank you.
See
Yeah,
you.
they're talking about Redshift at the moment. Okay. Thank you. Cheers.
Yep. Good.
Okay. Thank you. Right. So that's it. I think another end of a tack on Einstein's relativity session. So the question is Einstein's relativity fraudulent science? Okay. And I suppose it's still a question mark. But us distance, you look at Einstein's papers on relativity, we decide it doesn't really make sense. He's saying things that need a lot more clarifying. And in his mathematics is a mess. Okay, thank you. Bye then. Cheers. Bye. End session. Cheers. Bye then.